Welcome back to our iGEM Academy video series on using MATLAB. In this video we'll be discussing variables. First of all, a variable or scalar is defined by Wikipedia as a location paired with a symbolic name, the identifier, which contains some known or unknown quantity of information referred to as a value. So in MATLAB, a variable is simply an identifier whose name is chosen by the user, and a value which is assigned to the identifier by using the equal sign. Now when naming your identifier, some rules have to be followed. First of all, it has to start with any letter, followed by either letters, numbers or underscores, or a mixture of the three. That means you cannot use white spaces, use underscores instead. No digits are allowed at the first position, so no 0 to 9. No keywords, so for example for or while are keywords. These cannot be used as an identifier name. If you are unsure whether something is a keyword or not, use the isKeyword function to check. Be descriptive in naming, so not just single letter abbreviations. This will help you and others to understand your code more easily. No extra characters are allowed, that is things such as hashtag or $sign, and finally MATLAB distinguishes between upper and lowercase letters, so keep that in mind. The value that is assigned to the identifier sort of determines the data type. That is because MATLAB is weakly typed as opposed to strongly typed, so the data type is set by MATLAB and not the user. This is quite useful as MATLAB allocates the right data type and allocates the right memory amount. You do not have to worry about this. So if you assign the identifier a to a number, let's say 3, MATLAB automatically creates the variable a with a data type as set as a numeric double seen in the bottom of the image. All numbers are stored as doubles automatically. You can convert to 8-byte integers and others to save on memory, for example see the table. But that is nothing we need to concern ourselves with in the beginning. The main classes we will be looking at are logical for Boolean values, char for strings, and numeric for numbers, and also a little bit of cells. Now one more question, what do you store in your variable? Pretty much anything you want, so long as it can be represented as a number or as a string. So that could be the price of a product, a weight distribution, or a whole image, as this is simply an array of numbers. Let's look at that in MATLAB. Now first of all in MATLAB, let's create some variables by assigning some values to identifiers. First I want a string containing the sentence hello world. Now I want a string containing a number 1, 2, 3. Notice the char data type over in the workspace. Now let's create some numeric variables. First the number 1, 2, 3 again, but this time as numeric data type. Secondly, let's create a row vector from 1 to 10. We can either type out all the numbers or use the colon operator to let MATLAB work for us. We simply set the range from 1 to 10 and the rest is filled in and we get a nice row vector. I also want a column vector from 1 to 10 but only with the uneven values. So let's do the same thing but add a number in between which sets the step size. Now we have a beautiful row vector from 1 to 10 with only odd numbers. But remember, I wanted a column vector. Transform your row vector simply by using the apostrophe operator and reassign it, and you will get your column vector. Lastly, we will create a 3x3 matrix using the semicolon to create new rows. If we assign a value without picking an identifier, MATLAB simply assigns it to ants. This is, however, not a good long-term storage solution as it quickly gets overwritten. To check what variable names you already have used, use the who command. To find out additional information about your variables, use whos. This gives you an overview of their array size, size in memory, which is dependent on data type, and their class. Using the class command, you can also get the data type of your variable, as seen here. The size command gives you the array size of your variable, so the 1D row vector has a size of 1 by 10, meaning 1 row and 10 columns. As you have probably guessed, the column vector gives us a 5 by 1 size. The matrix is of 3 by 3, 3 rows and 3 columns. Our number 1, 2, 3 is of size 1 by 1, 1 row and 1 column. So is the string 123 also one row and one column? No, it's one row and 3 columns, as each string character gets stored in its own array unit. Now let's check our string Hello World. It is a 1 by 11 row vector with each character stored in one array unit. Even the white space here has its own unit. So we have noticed that all data types are stored in multi-dimensional arrays. What is an array? An array is simply a collection of objects of the same size and data type. Now MATLAB does differentiate between array structures. A 1 by 1 array would be a scalar, and it can, for example, store a number or a single character of a char data type, such as the letter H here. Notice that larger numbers, such as 11, do not take up 2 units of the array, whereas a string consisting of HE, for example, would take up 2 units. That brings us to the vector. MATLAB differentiates between row and column vectors. Here is an example of a row vector from 1 to 5, and one containing the string hello, where each character gets its own unit in the array. Finally, we have matrices, which can be multi-layered, but that is not something we will look at right now. Storing everything in arrays is extremely useful, as it makes manipulating and accessing parts of variables very easy, as we will see next. Just before that, we will look at some commands that tell us something about the array structure. Here is an example. IsScalar identifies if we have a 1 by 1 array. So let's use it on some variables and see what happens. Using isVector on our row vector obviously returns true. Using isMatrix on it does as well, as a row vector is also a 1 by 5 matrix. However, using isVector on the matrix itself returns a false. IsMatrix on the matrix itself returns, of course, a true. And last but not least, IsScalar on a matrix gives false for obvious reasons. Next we will manipulate those arrays. Here we have our matrix. I want to get its first entry, so I will index it in the first row, first column as shown. And voila, here we have it. How do I get the 8? Simple, just index to the third row, second column. Now we will do something a little bit more tricky. I want the complete first column, that is the entries in the first, second, third row and first column. To do so, I use the colon operator, which indicates that I want every row, and a 1 for the first column. Swapping a 1 for the 2, I'll get the whole second column. To get a submatrix, such as indicated, I don't want all rows anymore, but rather just 2, so I specify that the vector from 1 to 2. If I want all columns, I use the colon operator again. This way I can even access strings. The first entry is the first character of the string, so in this case H. If I want hello, I have to specify to get unit 1 to 5. As well as just accessing parts of an array and storing them for later use, we can also change an array or parts of it. I want to change the matrix's first entry to a 10. We already know how to access the first entry, so all I have to do here is assign it a different number, 10 in our case. I can also change the whole column this way. Access it as shown earlier and let it be equal to another column vector of the same size. So here, a 1 by 3 vector with only 10s. Using this method, I can also delete entries by first specifying what I want to delete, then let them be equal to an empty array of appropriate size. The last thing we will do for this video is have a look at cells. As we said earlier on, MATLAB can only store variables of the same data type in an array. So if we want to store a number, a vector and a string in one variable, we have to create a cell, as a normal array does not work as shown on screen. A cell is a sort of specialized array which can hold different data types or strings of different lengths. Let's look at what happens if we have a vector with 2 strings. Here we can see that MATLAB concatenates the two. If we store them in a matrix, MATLAB throws an error as they are of different lengths. So we would have to add 2 white spaces to the end of by to be able to store it, something we obviously don't want to do. So to create an array as described earlier using the curly brackets. Using the curly brackets, we can now access entries of the cell as seen here. Thank you for watching. This has been the iGEM MATLAB series, and this video has been on variables. Our next video will look at operators.